Welcome to investment video number 1. So, what do investors want? The answer is simple. They want to increase their purchasing power. The amount by which they want to increase their purchasing power will, if they're rational, be tied to their appetite for taking on risk. There exists at least one, probably many, risk-return relationships. And much of what investments is about is trying to recognize risk-return relationships when we see them. Okay, but I think it's fair to say that a rational investor would like to increase his or her purchasing power as time passes. That simply means that if you earn a 5% return and inflation is 6%, that you would not be increasing your purchasing power, and that would not be good. Okay? So, performance of investments is something that people monitor constantly, and so we need some way to quantify the relevant dimensions of performance. And generally there's two dimensions. The first is return, the second is risk. And calculating returns is fairly straightforward. There's several tools we use, and I'll talk about them in a moment. Calculating risk is more complex. There's a lot of economic phenomena that underlies interpretations of risk itself, and we'll talk about that. But right now, we're going to focus on quantifying returns. So let's talk about investment returns. The first one that we'll talk about is called the holding period return, the HPR, holding period return. And so I'll call it number 1, and it's HPR, holding period return. And it's fairly simple. It's calculated as so we'll call it the HPR, and it's calculated as the value at the end of a period less the value of that same asset at the beginning of the period divided by the value of that asset at the beginning of the period. So it's E minus B over B, ending value minus beginning value over beginning value. Fairly straightforward. So the HPR can also be stated as this, of course, E over B minus B over B, which is the same as E over B less 1. E over B has a name. Okay, I mean, it's just the ratio of relative prices, price at the end divided by price at the beginning, just a ratio. And not surprisingly, it's known as a price relative. A price relative, that's a V. Okay, so the HPR can be said to be equal to the price relative minus 1. It's probably most commonly thought of as ending minus beginning in the numerator and beginning value in the denominator. That's the HPR. So if we have an investment horizon, say of 5 periods, and so there's date 0, there's date 5, and the value at date 0, maybe it was 10,000, and the value at date 5, maybe 15,000. Okay, then E minus B, the HPR for this investment horizon, which happens to be 5 years, or 60 months, or a whole lot more days, and a whole lot more hours, and a whole lot more minutes, and a whole lot more seconds, depending on how you want to look at it. Doesn't matter, but this is our investment horizon from here to here. Okay, that HPR is then equal to 15,000 ending value minus the $10,000 beginning value divided by the $10,000 beginning value, or 5,000 divided by 10,000, which of course is equal to 0.5, which of course is equal to 50%. Okay, so pretty straightforward, simple. The HPR is ending value minus beginning value over beginning value. It's also equal to the price relative less 1. Okay, and the investment horizon is the time period that we cite in our description of the 50% return. We would say during our investment horizon, our HPR was 50%, and we might say that our investment horizon was 5 years or 60 months or whatever. Important point to realize is that the investment horizon need not be a single year. It can indeed be whatever you want it to be. Okay, so that's the HPR. Well, a second measure of performance is the arithmetic mean periodic return. So arithmetic mean periodic return. If we're talking about years, instead of the word periodic, we'd have annual. So keep that in your notes like that. So arithmetic mean periodic return could be arithmetic mean annual return, could be arithmetic mean monthly return, could be whatever. And it's simply equal to the HPR divided by n, where n is the number of periods in our horizon. Okay? So in our prior example, we had 5 years. So we could talk about our arithmetic mean annual return, in which case we just take our 50% and divide by 5. And that would give us, of course, 10%. Okay? Our arithmetic mean annual return is 10%. Okay? If we're talking about months, okay, then the arithmetic mean monthly return, okay, would be the HPR, 50%, divided by 60, okay, which would be equal to 0.0083 with a line over it. Okay. Again, this is just 0.5 divided by 60. Okay. So, because 50% is 0.5, and anyhow, so it's a little less than 1% per month. Okay, of course, 1% a month would be 0.01, so this is a little less. All right, so that's the arithmetic mean monthly return. AMPR really gets at the concept of a simple, kind of a simple return. Just a second, for some reason my pen's not working. There we go. Simple return, like simple interest, and it's really not all that valuable, but it's important to know, but it's not all that valuable. So so we'll just move on. I guess it's important to show you how you don't calculate an arithmetic mean periodic return. Here's a pretty neat example that shows you what you don't want to do. For example, there may be a temptation to calculate one-day HPRs and then to just average them and call that some sort of an average return. Okay, so we calculate one-day HPRs, then average them. Average them means sum them up and then divide by n. So sum the HPR sub i's and divide by n. And what I want you to realize is that this is a bad idea. Okay, make sure you understand that what I'm showing you here is a bad idea, and importantly, I want you to know why it's a bad idea. Here's why. So at date 0, let's say there's a cash flow. You make a deposit into an account, or you buy something that has a value of $5,000. And then at date 1, the value is $7,500. And so the HPR for the first period, I'll call it HPR sub 1, is equal to, you can just see it again, 50%. Okay? And then let's say that's the HPR for period 1, from here to here. And then let's say at date 2, the value ends up going back to 5,000. So then the HPR for the second period would be, think about it, it's going to be ending value 5,000 minus 7,500 over 7,500, because 7,500 is now the beginning value when we're calculating HPR for the second period. And you can see this is going to give us minus 2,500 over 7,500, which is minus 33.33%. Okay, so this HPR is, again, negative 33.33%. Okay, so let me just mark that off. Okay, this little chart area here. Alrighty. Now, let's see what this means. Now, the first thing I want you to notice is that we started with 5,000 and we ended with 5,000. And so nothing happened. As a matter of fact, if we are in an inflationary period, we lost purchasing power. Well, but if you just average these, okay, then we got two observations, 1, 2, and so they'd be equally weighted. So we'd have the measure of return. I'll just call it average return, whatever it is. It's wrong, but whatever it is, would be the 50% times 0.5 plus the minus 33.33% times 0.5, right? Because they're just being weighted equally. And then when you do the arithmetic here, you get 25% plus, or rather, minus 16.2%, and which is plus 8.13%. But of course, we didn't earn 8.13%. We really earned nothing if you just look at nominal values. And so this way of calculating some sort of an average return is wrong. And don't forget that, because sometimes that might pop up in work you end up doing, and it's a bad idea. This is an extreme example, but extreme examples are good to make subtle points easy to see. Okay, so this is just some sort of an average return. It's not an arithmetic mean periodic return, but it's just something that I think you should be aware of. Okay, so let's go on to a third return. Okay, the third one is going to be geometric mean periodic return. So geometric mean periodic return. Okay, and again, if it's a year, it would be geometric mean annual return, right? So just to remind you that that's what goes on there. So, and the formula for GMPR is simply this. It is we start with the price relative, and you take the nth root, and then you subtract 1. And that is the GMPR, geometric mean periodic return. So, for our example that I'll continue with here, we had 15,000. Oops. $15,000 divided by 10,000. Nth root, well, there we had 5 periods if we're talking years. The 1/5 power less 1, that would be equal to our geometric mean annual return. Notice there's an A there now because I'm just describing it as the annual return, okay, because we have 5 periods and we recognize those as years from our earlier analysis. Okay, so and to the 1/5 power less 1, and let me see, what is the 1/5 power, of 1.5? Hey Siri. Hey Google. What's 1.5 to the 0.2 power?
Sorry, I don't know how to help with that.
Hey Google.
There are other things.
What is the 5th root of 1.5?
5th root of 1.5 is approximately 1.084.
Okay, so that is 1.08447 minus 1, of course, is 0.08447, which, of course, is equal to 8.447%. So here we see that the geometric mean annual return is 8.447%, geometric mean annual return. All right, I'll remind you the HPR was 50%, and the arithmetic mean annual return was 10%. Okay, so let's go on to our 4th measure of return, and this is called the continuously compounded return, CCR. Okay, so our 4th measure of return is the CCR, continuously compounded return, and it is simply calculated. So the CCR is simply the natural log of the price relative. Okay, it's that straightforward. The natural log of the price relative. So it would be in this case, the CCR is the natural log of 15,000 over 10,000, which we already know to be 1.5. So it's the natural log of 1.5. Hey Google, what's the natural log of 1.5?
The answer is approximately 0.405465.
Okay, and we see that CCR is 0.405465, which of course is 40.5465%. Okay, and that is the CCR. Note that the CCR is for the entire period, which in this case is 5 years or 60 months or a whole lot more days. And let's now look at our 5th way of quantifying returns, and this is the periodized CCR. And again, periodized could be annualized, okay? And it's kind of easy. The periodized CCR is just the CCR divided by n, where n is the number of periods. So if we're talking about years, it's the annualized CCR. If n is measured in months, if n is the number of months, then it's the monthly CCR. And so in this example, the annualized CCR is simply 40.5465% divided by 5. Hey Google, what's 40.5465 divided by 5?
Sorry, I don't know how to
Hey,
help with
Google.
that.
What is 40.5465 divided by 5?
Sorry, I don't know how to help with that. Here are other things you can try.
Okay. That's 8.1093%. So our annualized continuously compounded return is 8.1093%. And so here we've seen 5 different ways of quantifying returns. Important that you realize that all of these ways of quantifying return are describing the same phenomena. And just to kind of remind you what that was. That phenomena was simply that at date 0, something was worth 10,000, and 5 years later it was worth 15,000. And we talked about different ways of talking about that change in value. We talked about HPR. We talked about arithmetic mean annual return. We talked about geometric mean annual return. We talked about continuously compounded return, and we talked about annualized continuously compounded return. Okay, so those are our 5 ways of quantifying returns, and important for you to realize that this is what those values were. 50%, 10%, I have to go back because I don't remember, 8.447%, CCR was 40.5465%, and the periodized or annualized CCR was 8.1093%. Okay, so these are just 5 different ways of talking about the same thing, and you get different numbers. My point here is it can be confusing to people, okay? And a good financial advisor will help clients understand what is meant by these various ways of quantifying returns. A good investment advisor doesn't try to confuse people. Okay, so that's enough for this video. Thanks for watching.